There we go. Okay. Okay. All right, so now again, we have our unknown side, right? So now what we're going to do is, okay, now what we're going to do though is we can get all the trig functions. You know, sine of theta we have already. That's opposite over hypotenuse. Cosecant is 1 over sine. So that's 1 over this, which just like the other example is 3. You know, 1 over 3, that's 3. Cosine of theta, adjacent, hypotenuse, adjacent over hypotenuse. So we get this. For secant, that's 1 over cosine, right? 1 over cosine is 1 over this, which means you flip the fraction. And for tangent, we have opposite 1 over hypotenuse. Then cotangent is 1 over this, 1 over 2 radical 2, which is this. So, all right. Okay, so we have that. Now, let me just, before I get to these, let me just ask this. Okay. No, I can't see your faces, so that's why I'm doing this. This poll. I really hope it does, because so I know this stuff's not easy. That's why I'm asking. So, oh, all right, good. Okay. All right. So the next stuff here, this is going to be a little bit different. What I'm just going to outline a proof, so to say. You know, you might, in other words, in these examples, right? We found sine of theta, cosine of theta. We were given it. We never knew what theta was exactly. So you might wonder, well, how do we figure out sine of 40 degrees? Or how do we figure out what tangent is of 10 degrees? You know, how do we get those numbers? How do we get those answers? Well, there are proofs and other identities one can use. And that's, I'm guessing, what the Greeks did back then, although they didn't have calculators then. So I think what they had was tables, I think, that had all the answers in them. But I could be wrong about that, though. But what we can do is we can determine, you know, sine and cosine of 45 degrees, for instance, using special kinds of triangles. I mean, what's nice is you don't have to memorize sine of 45 degrees. It's in your calculator. You don't have to memorize or even consult the table of what cosine of 40 degrees is. You know, again, it's in a calculator. You have a calculator in your phone, you know, you're at a computer, I'm sure your computer has a calculator like that in it. And you can use Desmos, of course, also. I just thought it'd be good, I've done this in the past, you know, to just outline just outline how you get certain trig functions from special triangles. For instance, let's suppose we have an isosceles right triangle, where both of the equal sides are 1. It really doesn't matter, actually, if instead of 1, I called this 2 or 3 or whatever. I'm just calling it 1 for convenience. I mean, where does this triangle come from? I mean, you could take a square of side length 1, or any side length. So, okay, well, how does that help us? Well, again, this is the right angle, so between these two, you know, again, so you can imagine taking this triangle and rotating it to get this. So isosceles means 2 of the sides are equal. The equal sides I'm calling 1. The third side, which is the hypotenuse, I'm calling it C. And of course, you can get C using Pythagorean's theorem. But how do we get 45 degrees here? How do I know that? Well, remember, if you have the angles in a triangle, And if they have to add up to 180 degrees, as I have here. Well, 90 degrees is accounted for already. So these two would have to add up to 90 degrees. And how did I know ahead of time that they're equal? Because they're opposite equal sides. Okay? They're opposite equal sides. Now, if you have angles that are opposite equal sides, that forces the angles to equal each other. How do you prove that? Off the top of my head, I honestly don't know. I know it's a fact, though. Okay. So since these two are equal and they add up to 90 degrees, that forces them to be 45 degrees. So we go from this triangle to this one as before. So this is 45 degrees. I mean, this angle is also, even though I didn't write it in. And to get C, remember, as Pythagorean's theorem, right, we have 1 squared plus 1 squared. That's equal to C squared. Okay, so from here we have C squared is 1 squared plus 1 squared, which is 1 plus 1, which is 2. Well, if C squared is 2, that tells us C, this side, must be radical 2. The square root of 2, that is. Okay, now this is good. We have a right triangle, right? We have an explicit one where we have the angle as 45 degrees. We know all the side lengths. So this tells us we can figure out what sine and cosine of 45 degrees are. And remember, once you know sine and cosine, you can get all the trig functions because they can all be expressed in terms of sine and cosine. Right? So from here, for instance, how do we get sine? Well, sine of 45 degrees is opposite divided by hypotenuse. So sine of 45 degrees is 1 over radical 2, which by rationalizing you get this. You know, you would multiply top and bottom by the square root of 2. I'm pretty sure I went over rationalizing denominators earlier in the course. Cosine also is adjacent over hypotenuse, so that's also 1 over radical 2, which is the same as this. Now you could see this from the triangle, but even if somehow the triangle is not there anymore, you know, it disappeared, I don't know, but you could still figure out tangent though. This tangent of 45 degrees is sine over cosine. But these two are the same. That forces tangent to be 1. Okay, good. And here I just went through how to convert 45 degrees to radians. I think we actually have done that before. That's pi over 4. And again, we have all these values. So these is just the values up here. Excuse me. Now, even though I don't have it here, you could figure out what secant, cosecant, and cotangent are. In fact, secant and cosecant, if you looked at those reciprocal identities or the definition, you would actually get 2 over radical 2 for those. You would get 2 over radical 2 for those, which is the same as just radical 2. Cotangent is 1 over tangent. That's 1 also. I mean, I don't have it written here, but really the most important stuff is what's written here. You know, you can get the other trig functions from this. And I also wrote it in radians, you know, same idea. Okay. All right. Now that's how we get sine and cosine of 45 degrees. Again, how do you actually get sine and cosine of the other angles, like 40 degrees or something? Off the top of my head, I honestly don't know. I'm guessing somehow they either do some trick or consider another special kind of triangle. Okay? But again, that's okay. We don't have to know that. All right. Now, so that was 45 degrees. It turns out also you can actually come up with sine, cosine of 60 degrees. You can do that. basically what you could do is consider, okay, well, let's consider an equilateral triangle. That's a triangle where all the sides are equal. Now you might be thinking, wait a minute, why is each side of length 2? I just chose that for convenience. Again, I'm not going to go through the calculation. It gets a little, it's not terrible, but if instead of 2, I put a number like x, an unknown number, we would actually get the same answers we're going to get. So we have this equilateral triangle. Okay, well, that tells us all the angles are equal. They all have to be 60 degrees. Then, as I wrote down here, if we were to draw the angle bisector in, I'm not sure how exactly you do that, but it could be done though. Okay. What that tells us is this is the perpendicular bisector. That's why I have these big rectangles, big squares here. And we get these two triangles. You could also show by side angle side, these two triangles are congruent. Now using the right triangle here, the right side, the one on the right that is, which is here. Again, this is 30 degrees. The whole thing is 60. You have the angle bisector cutting it in two. Bisect, cutting it in two, equal. So each one is 30 degrees. Excuse me. Since this side, to go back and forth like this, since this is a perpendicular bisector, this side length is 1. So you're cutting the side down here in 2 equal parts. So we have 1, 2. This side we don't know, the height. Can we get that? Yeah, Pythagorean's theorem. That's what I do here. And it turns out from Pythagorean's theorem, the height is the square root of 3. Just